So, what is my domain for this first one? X is greater than or equal to 0. Because I just have an X underneath there, and whatever's underneath there, I set greater than or equal to 0 and so on. Okay. So we do our little chart. We do 0, and then the values that I use, let's make them so that they come out nice. So pick some values for X that we can easily take the square root of. In other words, don't use 2, because the square root of 2 is not perfect, right? But 1 might be a nice value. So at 0 we get 0, at 1 we get 1, and what would be another nice value? We would get 2. So we have a beginning point, 1, 1, 4, 2. And how is this tail supposed to go? Up so that it goes parallel to the y, or out so that it's parallel to the x? Parallel to the x. All roots go parallel to the x, and we're done. Easy? Yeah. Okay, you've done a lot of this thinking on this worksheet that I gave you. Okay? But we're going to do some moving. We're doing some moving. Okay? All right. Here, x is what? Greater than or equal to 2. X, y. Let's see what that 2 does. If x is 2, y is 0, what should I let x be now? That comes out nice. There's a smaller one. 3, and I can get 1, and then 6 will give me square root of 4, which is 2. So at 2, I'm at 0. At 3, I'm at 1. 6, I'm at 2. So what did this 2 affect? What did it do between the first graph and the second graph? It moved it to the right. How many places? So minus 2 underneath means right 2 places. If I'd have had negative 3 underneath there, then I would have moved it right 3 places. What happens if I would have had plus 3 underneath there? I would have gone left 3 places. Does that make sense? Okay. Cubic roots, pretty easy. X is an element of the reals. Oh, I forgot my domain. What was my domain on this first one? Y was greater than or equal to what? 0. Here, y is greater than or equal to? Also 0. Range. Y represents your range. Okay, x is an element of the reals, and so is y. Okay, so cubic root parallel to which axis? Cubic root. Cubic root parallel to x or the y? Cubic root. All roots are parallel to the x. All exponents will be parallel to the y. All right. Now, what you want to do here when we deal with cubic roots and there's stuff going on is you want to first pick the value that makes what's underneath there 0. So where do we want to start? At negative 2. At negative 2, I get 0. That's your point of inflection. Remember, cubes and cubic roots will have points of inflection, so you want to locate that point first. Pick a value before negative 2 and a value after negative 2. Something that when I add 2 to it, I can take the cubic root, or I subtract 2 to, yes, so that I can, a value that gives me a cubic root. So what's a good value before negative 2 that I can take the cubic root of when I simplify it down? Doxy? Give me a value for x that's around negative 2, that when I add 2 to it, I can take the cubic root of it. Like I would use negative 3. Negative 3 plus 2 is What's a cubic root of negative 1? What's another value? Now, that's the value less than negative 2. What's a value greater than negative 2 that this will work also? Ellie? Negative 1. Negative 1 plus 2 is 1. Cubic root of 1 is 1. So our point of inflection is at negative 2, 0. We know at negative 3 we're at negative 1, and at negative 1 we're at positive 1. So it's going to come parallel always and do a little inflection at the point negative 2, 0. Okay. All right, so we got two things going on in the next problem. I've subtracted this 3, and I've made this negative. So somehow, if this is our parent graph, we're going to do something to it. What do you think the 3 is going to do? Huh? Okay, maybe move it to the right. Okay, so it's going to move it in some way. And what's this negative sign going to do? Anybody know? Have an idea? Huh? Opposite directions, what? I mean, in terms of then make it x and y's? I mean, make it go up and down? Other quadrants. So it's going to reflect it. Okay, let's see what happens. So, x and y, we know x is an element of the reals, as is y, because we're dealing with cubic roots. We're going to start again at negative 2 because that's what gives us 0. But at negative 2, what do I get as my final answer? Negative 3. So we're going to go ahead and use negative 3 again because that gives us negative 1 under our root, which we can do. The cubic root of negative 1 is negative 1, but then I have this little negative sign under here, which makes it really positive 1, and then I subtract 3, so now I get negative 2. And then the next value that I'll use is I'll go ahead and use negative 1. Usually if you use 1 to the left and 1 to the right of your point of inflection, those always work nicely. Okay? So negative 1 gives us 1. Cubic root of 1 is 1. Now it's negative 1, and we subtract 3, and we get negative 4. So let's look at this graph. Our point of inflection is right here at negative 2, negative 3. Okay, our point of inflection was at negative 2, 0. Now it's at negative 2, negative 3. Tell me again what this 3 did. Did it move it right? It moved it down 3. So it affects the y answer, doesn't it? So if it's underneath with the x, it affects the x. If it's outside, it affects the y. Always. That's what you can expect with your graphs. All right, at negative 3, we get negative 2. And at negative 1, we get negative 4. So Katerina was right. We are switching and flipping our picture. We're starting high and going low versus starting low as we look left to right and going high. So this is an example of what positive cubic roots will look like versus negative cubic roots. Okay? So the sign flips it and the numbers do the shifting, left to right or up and down. Yes? Point of inflection is where it turns. So it's going down, 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 and now it goes up, kind of. Curves it the other way. All right, let's try this one. You do that one yourself. It's a square root. Not negative 3. You want to use this as your first one, don't you? Right? Okay. Hmm? What? Your domain defines your first x. And I'm dealing with a square root. So I got to set what's underneath there greater than or equal to 0, and that defines my first x that I can use. Does that make sense? Well, when you plug in this value, then you get a 2, don't you? So if you substitute in 3, you're going to get 2 times 0 plus 2, which is just 2, isn't it? Yeah. So your point is 3, 2. Would you agree? Does that make sense? Our charts will be probably pretty similar because we're going to be trying to find values that we can take square roots of. Okay? And it's going up, but it's going up to the right, not up straight. Okay? All right? How many of you got this one right? Raise your hand if you got it right. Okay? Who's got a question on this? Doxy? If x is 3, this is my first y. What are my y's doing? Getting bigger, right? Okay, do the next one. In your mind, this is a cubic root, and it's negative. Is it going to look like your first graph up here or your second? Second one. It helps to know what you're graphing, okay? All right, so figure out, your x is an element of the reals, as is y. So come up with your x and y chart. Because our tails are going in both directions. Our y is going to increase and decrease also as our x increases and decreases. What is our point of inflection going to be on this one? What x value? At 3. That's our point of inflection at 3, and that gives me negative 2. This is my point of inflection right here. Does that make sense? Because that gives me 0 under that cubic root. A value before 3 that I could use would be which one? 2. At 2, I would get negative 1, negative 2, what, negative 4? Is that correct? No, is that right? Negative 1, 2, 0. Is it 0? Oh, now I did the wrong one. So this at 2, I should get 0. Which means at 4, what should I get? I get negative 4. So it's coming up high, dropping down, and going negative along the y-axis. And so it does look just like the second one that we did up here. Okay? Anybody got a question?